This is first year University Mechanics, University of Windsor. And what I'm going to be solving here is just some simple problems. It's about halfway through the semester now, so it's a bit late. But hopefully this can help some people. In the future I'll probably post more, maybe on some other subjects as well. So we'll get started with the first question. This is our drawing surface. Just so it's easier on your eyes, we'll change the background. I have white or black. And there we go. So we'll get started. I'll draw the first question, and so we have an airplane. I can't draw with crap, so I haven't drawn the airplane. I just drew the points of interest. So we're given that the weight at point A, and point A, this is point A. The weight at point A is 45,000 pounds. We have that the weight at point B, right here, this weight is 8,000 pounds, and the weight at point C, here, this is 6,000 pounds. I haven't drawn that on there because the diagram's already pretty cluttered, and it looks like crap. So really, we don't need those to solve it. We just need these measurements and these weights. So, actually, make sure you copy this down because it'll definitely be of use. Maybe draw a little airplane if you want. I don't know. So, we'll get to work, I suppose. So, what should we do first? Well, let's take a look at this. Supports F, D, and E are what we're looking for. We're looking for the reaction forces. Those are all wheel supports. So, let's write that down, because I didn't. Sorry if my writing is extremely difficult to read. I try. So, these are wheel supports. And then they're in 3 dimensions, so they're wheel supports. We know we're just going to have reactions in the positive Z. And since these are weights, they're going to be in the negative Z. So the first thing that we do is we have to try and figure out something that we can, equate these with. Can we use the summation of the forces in the Z? Well, if you use the summation of the forces in the Z, you get an E, you get an F, and you get a D force, which doesn't exactly help us. It gives us the same unknowns. We do summation of the forces in the Y or the X. I don't think that works very well either, because as you can see, there's no component of any of the forces in there. You just get 0 equals 0. What we're going to do is we're going to do the summation of the moments about the coordinate axes. The summation of the moments. So we'll do summation of the moments about the x-axis. Sigma moments about x. And we'll consider this direction to be positive. So, if this is an equilibrium, which we're assuming because this is statics, this should be equal to 0. So, what do we get? Well, about the x-axis, so this is our positive rotation if it's going that way. Well, what do we have? We have force at, did I draw that right? Yeah, force at A, this is A, right here. That's on the x-axis, it's not going to create any moment. We have the force at C. C is 6,000 pounds, that's going down because it's weight. That's going down this way. Well, what's that going to do? That's going to rotate this clockwise. So, we have negative 6,000. I'll use the units because units are important. You got to remember the units. And that's at 8 feet. So 6,000 pounds at 8 feet, negative. And we have force at E. That's going to be acting up. We're going to be getting positive moment plus force at E. How far away is that? That's 14 feet. What else do we have? We have the force at B right here. That's 8,000 pounds. It's going down, so that's going to create a clockwise moment, plus 8,000 pounds, and that's acting at 6 feet. And then, what do we have left? We have this force D. And since that's going up on this side, we can see that's going to be a clockwise moment. So, minus FD, and that's at 14 feet. And this whole equation is equal to 0. So, we have two unknowns in this equation, so we can't exactly solve that directly. But we can certainly simplify it a little bit, which I'm not really going to do right now. It doesn't concern me all that much at this point in time. So, let's move on to the second equation, the moments about y. And I have to move around a little bit here, so bear with me. And we're in equilibrium, so that has to be 0. So, what forces create a moment about the y-axis? Well, any force that's not lying directly on the y-axis. So we can see here, force D, that's on the x-axis, so that doesn't create a moment. But force B, C, A, and F are not on the y-axis, so those will create a moment. So we'll have 6,000 pounds, that's force C, and we can see, well, anything going down on this side, that's going to be counterclockwise, so it'll be positive. And since this is the support reaction at F, that's most likely going to be going up, we're going to assume. That's going to have a negative moment. So this is going to be 6,000, and that's at 4 feet as well as B. It's hard to see by this, but that's also for B as well. So that's our FB, our weight at B, and that's at 4 feet. And we have the 45,000 pounds at A. Oh, you probably didn't see a lot of that because it's up here. Yeah, it's all up there. It's awesome and everything. And as I'm referring to it, you can't see our force at F, which now you can see. Our force at F, which is acting up. So that'll be a negative moment, minus F. I'm just going to call it F, because it's at F, and that's 27 feet. And this moment equation is equal to 0. So now what do we have? We have this whole moment equation, and we have only one unknown. So what can we do now? We can solve for this unknown. So F equals, take all of these, and take the summation of all of these values here. We subtract them from both sides. So we have F on this side, that on that side. And we divide both sides by negative 27. This is just going to be quick mental math. Probably around 13,000 or something, if I'm correct. 13,740 pounds. That's just hoping that's correct. If it's not, then write it down. I'm pretty sure it's correct. So now we have our force F. So we have that. Does that help us with anything specifically? Well, it might. It might not. We'd have to see. But if we see, we selected the x-axis and we selected the y-axis for our two moment equations down here. Well, what's so special about those axes? You know, why can't we just select something out here, for example? So that's exactly what I'm going to do. And sorry, that looks terrible. Let's draw this out here. So we'll use the d-axis. the x-axis, that is, and that's positive. So, summation moments about the dx-axis. That direction is positive. So what do we have? Well, we have force B going down. That's going to create a clockwise moment. A also going down. A also going down. That's going to create another clockwise moment. We have F, that's going up. That will create a counterclockwise moment. E will create a counterclockwise moment, and C, that's down clockwise moment, right? So, I'm not going to go back up to that because it's difficult to scroll with this pen, unfortunately, despite the fact that it says it's not supposed to be. Negative 8,000. So, our resulting moment equation is negative 8,000 pounds times 8 feet minus 45,000 pounds. That's our force at A, and that's at 14 feet from D. 14 feet from the dx axis. And then we get plus the value we got for F plus F, and so 1340 pounds, and that is also at 14 feet. And finally, we have the last two forces, minus 6,000 pounds, and that's at 22 feet. And running out of space on the edge here, so I'm going to do plus E, which is our reaction force that we're solving for, and that's at 28 feet. So, if you don't understand where these numbers and distances are coming from, try to go through this diagram and, figure out where they're coming from. Think about it like E, that's at 28 feet, well that's 8 plus 6 plus 8 plus 6. And you get all those distances. Just, it's good to know where those come from so that when you're actually doing them you have some clue as to what's going on. So you solve this equation, E, and again with the mental math. I'm terrible at mental math, so don't trust my numbers. We get something like 22,000, like 22,000, maybe 22,630 or something. And again, if I'm wrong, don't blame me. I'm terrible with numbers. And finally, we get to our last equation. Now, there's you get FD equals 22,630. And how do we get that? Well, FD is at that distance, FE is at that distance, right? So, therefore, if this is to equal 0, then logically it would have to be at the, you got 8,000 times 6, and you have 6,000 times 8. So those two are going to cancel each other out to be 0, right? Then you have 14 feet, 14 feet. If this is some value, this would have to be the same value for these to equal out to 0. So we'll just write our final concluding statement. And that's what we get. So if this helped you, then please comment, because currently I feel like I've just wasted about like 10 minutes. It'd be more efficient to do this one first, this one second, and this one third. Then you just solve them right down. But apparently I wasn't thinking that.